Hi friends, welcome back to the channel. This is Linovision. And this time we're going to share with you a use case. A client recently reached out to us with a problem. They need to install a 12-inch smart touchscreen in the lobby of the commercial building. The screen will serve as a digital directory. Mounted on the wall, the device runs on USB-C power, expecting either 5 volts or 9 volts. Typically draws between 10 and 15 watts. It also requires stable wired network connectivity to keep the interface responsive. The issue: the nearest AC outlet was inside the control room, nearly 50 meters away. Running an extension cord through the wall wasn't safe, wasn't compliant. And relying on Wi-Fi for mounted touchscreen in a busy building wasn't acceptable either. They asked us a simple question: is there a clean, engineered way to deliver both power and data to the screen without adding new electronic infrastructure? The first idea that often comes up is to use a long USB-C cable. But that quickly runs into physical limitations. USB-C cables aren't designed for 50-meter power runs. At low voltage like 5 or 9 volts, resistance over distance causes voltage drop. Once you move beyond just a few meters, the device may reboot randomly, flicker, or fail to power on entirely. USB-C works perfectly at a short range, but it was never built for building-scale power delivery. Another idea is to power the screen locally and rely on Wi-Fi for data. But in commercial environments, wireless network can be congested, unstable, and subject to interference. For the interactive smart touch screen that needs to be reliable 24/7, Wi-Fi alone isn't ideal. So we looked at the infrastructure that was already there, Ethernet. What if we could send both power and data over the single Ethernet cable? And that's exactly what a Power over Ethernet PoE does. PoE transmits DC power and network data together over standard Cat5e or Cat6 cabling. It's already widely used to power security cameras, access points, and IP phones. Under IEEE 2.3 AF and AO 2.3 AT standards, PoE can deliver up to 100 meters of 48 to 57 volts DC power along the fast Ethernet data on the same cable. That means anywhere there's an Ethernet infrastructure, you can deliver power, even if there's no AC outlet nearby. The only remaining challenge was the touchscreen still require regulated 5 or 9 volts through USB-C. That's where PoE-to-USB-C converter solves the problem. This compact adapter accepts IEEE 2.3 AF or AO 2.3 AT PoE through the RJ405 port, and it converts it into stable USB-C output. Inside is a high-efficiency DC to DC regulator and a USB power delivery controller that automatically negotiates the current voltage. It can output 5 volts at up to 2 amps or 9 volts at up to 2.22 amps, delivering up to 20 watts of regulated power, more than enough for most 10 to 15-inch smart touchscreens. Now, we don't have the client's exact touchscreen model in the lab today, but electronically, the requirement is straightforward: a stable 5 or 9 volts over USB-C under roughly 20 watts, plus wired Ethernet. So instead of a physical touchscreen, we're going to validate the solution using devices that behave the same electronically, such as a smartphone, a tablet, and a small laptop. For this installation scenario, we used a PoE switch capable of IEEE 2.0 output and a ran of 50-meter length of the high-quality Cat6 cable with a pure copper conductors. Using pure copper instead of copper-clad aluminum helps minimizing voltage drop and ensures the full available power reaches the far end. At the device location, we connected Ethernet cable directly into PoE-to-USB-C converter. An LED confirmed the power and data were present. Then, we used a short-started USB-C cable to connect the converter to our test device. Within seconds, the device powered on, receiving both stable power and a wired network connectivity over the single cable. Wi-Fi disabled, Ethernet active, power steady. This approach not only solves the installation problem, but it improves safety and reliability. PoE operates at a low voltage DC, typically between 48 and 57 volts, reducing shock risk compared to AC main wiring. The converter includes isolation over current and a short-circuit protection to safeguard equipment. And because the device now uses wired Ethernet instead of Wi-Fi, its performance remains consistent even during peak wireless congestion. The final result is clean, professional installation. One cable, no exposed power breaks, no electronic modifications. And this solution is limited to a smart touchscreens. The same PoE-to-USB-C approach works for digital signage panels, interactive directories, conference room controllers, wall-mounted tablets, Raspberry Pi systems, and remote IoT devices.